Howdy, AP PreCal, it's Miss Kosh. Today we are doing the section 315, the rates of change in polar functions. You know that AP wants to do rates of change with everything, so here we go. First of all, what I did is I used Desmos to help me out, and I graphed this as a rectangular equation. So I just graphed y equals 1 plus 2 sine of x, and I had it, I figured out how to generate a table. I may or may not have had to Google it. But I made a table of all these different values. I think I followed, and then actually you can get the Desmos to plot those points. And so you'll see like these little dots here are, oh, that pencil's not working. Let's try that again. These little dots here are from that table. So I was finding every pi over 6 away. So here are the dots that we generated. Notice on here, it gives us this 5.55, whatever, times 10 to the negative 16. Think about this, though, for a second. This really is, if I do, this was 7 pi over 6. If I have 1 plus 2 times sine of 7 pi over 6, 7 pi over 6, the sine value is negative 1/2. I have 1 plus 2 times negative 1/2, which is negative 1. 1 plus negative 1, anyway, that looks funny, but that's 0. But the calculator got a little confused and didn't know what to do there. Same idea here. It was probably they were estimating pixels or something, or, you know, it's more advanced than I really care to get into. But those two values are both 0. Okay, so then we're looking at this curve, which you know how to graph, and you know how to do that pretty well, I would assume. Here's all the points that we care about. And then we wanted to see, well, what happens when we make this a polar graph? When I graph not y equals 1 plus sine x, 1 plus 2 sine x, but instead this is graphing r is equal to 1 plus, nope, it's 1 plus 2 sine of theta. Okay, so these points, we have the point where theta equals 0. It's still the same table because Desmos does tables in the rectangular world, but think of this as being your theta value, and then here's r. Okay, so when theta equals 0, our r value is 1, and that's right here. This is 0, 1. No, it is not. It messes me up every time. What we have here is we graph this in the polar world. The polar world is r comma theta, but it's output comma input instead of input comma output like we've always done. So the r value is 1, the theta is 0. Okay, the next one, pi over 6, 2. Pi over 6 is labeled, and here's this point. So this has a radius of 2 and a theta of pi over 6. That one I said correctly the first time. Shocker. Okay, the next one, pi over 3, is about 2.7-ish. So that's this point here. Then we get to pi over 2 has a radius of 3. So this is the point r equals 3, and the radius is equal to pi over 2. So notice as we're moving here, one of the things that the calculus teachers were encouraging us is to put little arrows to show that we're going that way. Here would be 2 pi over 3, which is the next one, and has a decimal. I don't really feel like labeling that. This one is 5 pi over 6, and notice with 5 pi over 6, we have a radius of 2. So this is the coordinate r theta. Okay, then we get, after 5 pi over 6 comes pi. Pi has a value, we can look from the chart, pi has a value of 1. Well, that's not a correct statement. F of pi equals 1 might be a better way to say that. So this is the point 1 comma pi, r theta. And then what happens? Well, we get to 0 right here. Remember how we said a minute ago that these were, the calculator getting a little confused? That's 0. So at 7 pi over 6, we get, so from, this is going from pi to 7 pi over 6, right through here. And we're at 0. So that pole, the first time that we got there, it's 0 comma 7 pi over 6. And then it continues up this way to get to, let's see, when does it have a, actually here, if you notice, we're at 3 pi over 2 has a radius of negative 1, which means instead of coming this way, we're going to turn around and go the opposite way, and that gives us this point. So this is the point, r equals negative 1, and theta equals 3 pi over 2. And then we get back to the pole. Well, where else did we have 0 in our table? At 11 pi over 6. So this is now 0 comma 11 pi over 6. And then we cruise on back, and this point that was 1, 0 is also the point 1, comma 2 pi. So this particular graph, you may remember we call this a limacon. It's got an inner loop. It started here. Let's use a different color. So basically we started here and we cruise along like this, and then we come into the inner loop and then come on out, and it took us 2 pi to do that the first time, or do it once. Okay, so I'm going to get rid of that pink because I don't think I want it. So then it says on the interval from 0 to pi over 2, the R values are, okay, from 0 to pi over 2. So I'm looking at Y values from 0 to pi over 2. All of my radius were positive. So we can see that here, but we can also look back here from 0 to pi over 2 is here. So that's this piece of the curve. And maybe we can see more clearly that the R values are positive and increasing. So what happens here is that I started with a radius of 1, then I had a radius of 2, and then here was a radius, something getting closer to 3, and then here was a radius, oh, you don't know where I am. This is the radius getting closer to 3. This is the radius of 3. And so those R values were increasing as we went in that way. We can see the distance between the curve, so f of theta, and the origin, or the pole, is, well, that distance, so we started here, you can't see where I am. I'm used to you seeing my hands. We started here, and we were 1 unit away from the pole, but by here, we're 2 units away from the pole. So that, that distance is increasing. Okay, then what happens? Then we're on the interval, let me switch colors. Then we're on the interval from pi over 2 to 7 pi over 6. So pi over 2 to 7 pi over 6. Well, 7 pi over 6 happened all the way over here the first time. So that first time we got to 0. So we were cruising our, well, and then we can also compare that to here. So this is pi over 2 to 7 pi over 6. Now, why did I stop at 7 pi over 6? Because this is where my R values are positive still, and they're decreasing. Okay. Now, what happens is I move from pi over 2 to 7 pi and come this way. Notice the distance that I am from the pole. So, like if I'm here, this distance. Oh, that's a terrible line. This distance is smaller than that initial amount where we started. So the distance between the curve and the origin is decreasing. Okay, on the interval 7 pi over 6, so the reason I picked 7 pi over 6 is because that's where it went from being positive to being negative. Okay, now they're telling us 7 pi over 6 to 3 pi over 2. Let's see how, maybe I'll use blue. No, I'll use black. Okay, where were we? 7 pi over 6 to 3 pi over 2. 7 pi over 6 started us here. 3 pi over 2, that takes us to here. Those were, notice we're at the pole, and then we're getting farther and farther away from the pole. We get as far as 1 unit away. When we look at this graph, we were here, 7 pi over 6 to 3 pi over 2. Our values are negative and decreasing. The R values are negative and they're decreasing. Okay, but what happens is theta, so we can look at this table. 7 pi over 6 is here. So we were looking from 7 pi over 6 to 3 pi over 2. We have 0 at 7 pi over 6, and then we have negative values until we get to 3 pi over 2. So we know that those R values are negative, which means it moved back into 7 pi over 6 should have been down here somewhere, but it's not because we have to turn around and go, well, okay, 7 pi over 6 isn't the best example. This one, what would that be, 5 pi over 4? That we have to turn around and come back here to where it's negative. I'm going to get rid of some of those dots because that's annoying. Okay. So we were negative and decreasing, and while that happened, our distance from the pole, between the curve to the pole, was increasing. Then we look from 3 pi over 2 to 11 pi over 6. 3 pi over 2 is, let's try this color. 3 pi over 2 to 11 pi over 6 does something like that. Where are we in the rectangular world, 3 pi over 2 to 11 pi over 6, our R values are still negative, and it's hard to tell that they're negative on the polar curve down here, but it's a little easier to tell on the rectangular curve. Where are we? They were negative, and what are they doing down there? They're increasing. They're negative increasing, and so that means that the distance from the pole is decreasing. Notice as I start here, I'm farther away from the pole than I am as I keep going in that particular path. Okie dokie, one last little piece is from 11 pi over 6 to 2 pi. We are, our R values, so what were our R values from 11 pi over 6 to 2 pi? I think they're positive. Let's see over here. 11 pi over 6 to 2 pi, those are positive R values. And 11 pi over 6 to 2 pi is from here to here. And sure enough, that is in the correct quadrant that we want to be in. And they get farther, so they're, where were we? They are positive values and they are increasing. And that means that the distance between the curve and the origin is increasing. Oh my goodness, what have we concluded? Well, so what we're saying here is that in a polar function, if a polar function R is positive and increasing. Okay, let's look back to our little circle things here. So we had positive and increasing here. We had positive decreasing, negative increasing, positive increasing, and positive increasing here. What's happening is that then the distance between the curve and the origin is increasing. Now the other time it was increasing, let's see, was, this one's decreasing, is right here, and that's when it's negative and decreasing. Okay, so if a polar function is, if the R values are positive and increasing or negative and decreasing, then the distance between the curve and the origin is increasing. Okay, likewise, we can see what happens when they decrease. Well, so where does it say that it's decreasing? We circled decreasing here and here. So what were those scenarios? That was where it was positive and decreasing. Or, what was the other one? Negative and increasing. Okay, oh my goodness. Well, so we're gonna have to keep thinking through all this. I have a couple of examples that we're hoping to figure out. So on this one, this is a cardioid. And so what I might do is look at, okay, what is f of 0? Cosine of 0 is 1, so 2 plus 2 is 4. We can look at, okay, what's cosine of pi over 2? I lied. What's f of pi over 2? This is 2 plus 0 is just 2. And then f of pi, when I plug in pi, cosine of pi is -1, so this gives us 0. So this is going to look something like this, and then we're up here at, this has a radius of 4 and a theta of 0. Look, I did it correctly. Okay, this has a radius of 2 and a theta of pi over 2. And then we get back here, and then the one I didn't write yet was f of 3 pi over 2. Cosine of 3 pi over 2 is 0, so this is just 2. So we're down here at 2 comma 3 pi over 2. And it's that cardioid, that heart-shaped one, so it kind of comes, oh, I don't do a great job of drawing these. So it's something like that. Okay, so on this, what did we have? Another way to think about this is, what does this curve look like? Well, our cosine starts at, we'd have, this would be 4, this would be 2, and we're going to have a range now of 0 to 4. So we start at the top, we get here, and then this is, oh, pretend I can draw. Okay, so this was by 2 pi. So we are positive. Okay, so now on this interval, our R values are positive. Well, I wonder what happens at 0. I'm going to have to figure that out. At pi, we were at 0. Well, okay, so From 0 to pi, our R values are positive, and they are decreasing. So what happens when we're positive and decreasing? We're getting our distance. Okay, so state the intervals where the distance between f of theta and the origin is increasing. Well, that's not what was happening there. Well, this from 0 to pi is where the distance is decreasing. So if you look at this, here is the pole. Here's the pole. How far were we at first? We were 4 units away. By the time we get over here, we're 2 units away, and then our distance keeps getting smaller and smaller. Okay, then what was happening, if you think about this curve, what's happening from pi to 2 pi? Our R values are still positive, and now they're increasing. So positive and increasing tells us that distance is increasing. So our answer here is pi to 2 pi. Okay, let's try one more example before I call it a day on this one. Ooh, look what this one came from our calculus teacher. So what is happening? Whenever I take cosine and I square it, I'm only going to get positive values. So the biggest value that I'll ever get is when I plug in, say, 0. So say I have f of 0 would be equal to 2 times cosine squared of 0. Cosine of 0 is 1, 1 squared is still 1, and multiply that by 2 and we're at 2. The smallest value that we'll ever get would be something like at pi over 2. And so we have 2 times cosine squared of pi over 2. Cosine of pi over 2 is 0. 0 squared is 0. Multiply it times 2, we're still at 0. Okay, what's going to happen when I get to pi? We're going to have, this is 2 times cosine squared of pi. Cosine of pi is -1, but I squared, it becomes +1. Multiplied by 2, it's +2. And then I think this would also be equal to f of 3 pi over 2. Okay, I mean, it's not quite the same, but we're fine. So what are we looking at here? We're doing something like, we start at 2, we get to 0, we get back to 2, we get back to 0 at 3 pi over 2, and here's 2 pi. So we're doing something like this. So this was pi over 2, this was pi, this was 3 pi over 2, and this is 2 pi. And so our all of our values here are positive, so we're just looking at the top part of these. So positive and increasing is going to be where it's increasing. So where are we positive and increasing? Between pi over 2 and pi. And positive and increasing from union, 3 pi over 2 to 2 pi. Where were we decreasing? From 0 to pi over 2. We're going to pick it up again from pi to 3 pi over 2. And let's take just a second. Let's see if I can go to Desmos. Oh, there was something else I was doing for homework. If I have R, I have to come over here, R equals, oh, I just forgot the equation. Was it 2? Hang on. 2 cosine theta, close parentheses, squared. Aha, look what it does. So it does kind of this funny little, and maybe I can switch this to that axis. So we were at 2, and then it hit 2, both at, so this one over here, you know what, I'll add that to the, you get to watch me make my answer key. There it is. Okay. Go away. Okay, so we're looking at something like that. And so it was the distance from the origin was increasing when I went from pi over 2 to pi. We got farther and farther away. And then when I go from, it's also increasing when I go from 3 pi over 2 to 2 pi, something like that. And then it was decreasing from 0 to pi over 2, and then getting farther away from pi to 3 pi over 2. I think. I've never taught this before, you guys. Okay, hopefully that was helpful. Subscribe, keep watching, give me feedback. Let me know if that was beneficial. I do have a little bit more. We're going to talk about the extrema. So come back for the next video. Good luck.